Hi, welcome to Mathnaxtra. This is Saritha. Today I am going to start a topic of quadrilaterals. What is a quadrilateral first? So, a simple closed plane figure formed by four line segments. We call it as a quadrilateral. See, yes, these are the four line segments A, B, C, D. So this is one line segment, this is one line segment, this is one line segment, this is one line segment. So this simple and closed figure formed by four line segments, we call it as a quadrilateral. Okay. So we have to write this, name these vertices in the either clockwise direction or anti-clockwise direction only. You should not write A here and B here, C here like that. You should follow either clockwise direction or anti-clockwise direction. Okay. So these A, B, C, D are vertices of a quadrilateral. Okay. And this AB, BC, CD, AD line segments, we call it as the sides of a quadrilateral. Okay. Now, is this a quadrilateral? A, B, C, D. Is this a quadrilateral? Yes, it is a quadrilateral. See, it has four line segments. See, 1, 2, 3, 4. And it is a simple closed plane figure. Yes, that is why this is also called quadrilateral. Then what is the difference between these two? We have two types of quadrilaterals. That is, one is convex quadrilateral and other is concave quadrilateral. What is a convex quadrilateral? Convex quadrilateral. Convex. Convex quadrilateral is nothing but if each interior angles. See, these are the angles of a quadrilateral, right? A, B, C, D. Angle A, angle B, angle C, angle D are interior angles of a quadrilateral. So, if this each angle is less than 180 degrees, this angle is less than 180 degrees, this angle, each and every angle, interior angle is less than 180 degrees, then we call it as a convex quadrilateral. Okay. So, this is convex quadrilateral. Okay. What about this? See, this angle, by looking at this, we can easily say this angle is greater than 180 degrees. Yes, this is, these three are less than 180 degrees, but this is greater than 180 degrees. So, if any one of the angle measures greater than 180 degrees, then we call that quadrilateral as a concave quadrilateral. We generally use this convex quadrilateral in this lesson. Okay. Now we have to define some terms which are going to helpful while defining the properties of a quadrilateral. So what are those? What are adjacent sides? What are opposite sides? What are opposite angles, adjacent angles, and what is a diagonal? What is an exterior angles? We have to define all these because while defining the properties of different types of quadrilateral, we use those words. So if we have a complete idea about those, then the properties can be understood easily. Okay. Now, the first definition, first term is what are opposite sides. See, when we say the two sides are opposite to each other, see, these AB, BC, CD, AD are sides of a quadrilateral. If the two sides which don't have a common vertex, see, this AB side is one side and this CD side is one side. See, these two sides don't have a common vertex. See, AB, these are two different vertices. These are two different vertices, isn't it? So these two sides don't have a common vertex. That is why we call AB and CD are pair of opposite sides. Yes, this is a pair of opposite sides. Okay, and C, BC and AD. These two sides also don't have a common vertex. That is why we call BC and AD are pair of opposite sides. Okay, so these two are pairs of opposite sides. And what are adjacent sides? What are adjacent sides? Okay, what are adjacent sides? In the opposite sides, the two sides should not have a common vertex, but in the adjacent sides, the two sides must have a common vertex. See these AB side and BC side, these two sides have a common vertex B. That is why we call AB and BC are adjacent sides. Okay, what are AB and BC or adjacent sides? C, B, C, C, D. They have a common vertex C. That is why we call B, C and C, D are adjacent sides. Okay, B, C, C, D. Similarly, C, D, C, D, A, D. Okay, A, D, A, B. These are all pairs of adjacent sides. Pairs of adjacent sides. Okay, these are adjacent sides. Now, what are opposite angles? See, in a quadrilateral, we have four interior angles. That is angle A, angle B, angle C and angle D. Okay, these are four interior angles. Which angles are called opposite angles to each other? See, in the case of angles, we use the term arms of angles. See, if angle B is there and AB, BC are arms of this angle ABC. Yes. So, the two angles which don't have a common arm. See this angle B. It has a two arms AB and BC. And look at angle D. It has two arms CD and AD. So these two angles don't have a common arm. That is why we call these two angles as a opposite angles. See, angle B and angle D. These are pair of opposite angles. And look at angle C and angle A. See, angle C have arms BC and CD and angle A have arms AB and AD. So these two angles don't have a common arm. That is why we can say angle A and angle C are pair of opposite angles. Okay, so these we call as pair of opposite angles. And what are adjacent angles? What are adjacent angles? The angles which have a common arm, we call them as a adjacent angle. See, angle A and angle B, these two angles have a common arm AB, isn't it? See, angle A and angle B, these two have a common arm. That is why these two are adjacent angles. And similarly, angle B and angle C have a common arm BC, which are nothing but angle B, angle C are adjacent angles. Angle C, angle D, angle C and angle D are also adjacent. And angle D, angle A, yes, angle D and angle A. These are pairs of adjacent angles. Okay, we can define adjacent angles like this. And now, so this quadrilateral have four vertices. Those are A, B, C, D are four vertices. And this A, C are opposite vertices. And this B, D are opposite vertices. And this AB, BC, CD, AD. These are adjacent vertices. Okay. Now we'll define what is an exterior angle of exterior. Exterior angle of a quadrilateral. See, if we extend one of the side of this quadrilaterals, I am taking BC side, I am extending this side at one vertex. See, this BC side is extended to some D and this angle is formed. This angle we call it as an exterior angle of a quadrilateral. See, this angle DCD at the vertex C. So, if we extend one of the sides of quadrilateral, the angle thus formed at the vertex we call it as an exterior angle, and that is completely outside the quadrilateral. Okay. Similarly, we can form four exterior angles at four vertices. See, this is one exterior angle. This is one exterior angle. This is one exterior angle. Okay, and these interior angle and exterior angle at each vertex are supplementary always. If this is angle C, then what will become this is 180 minus angle C. If this is angle D and this is 180 minus angle D, if this is angle A, this is 180 minus angle A, and if this is angle B, this is 180 minus angle B. Okay. So always at each vertex the interior angle and exterior angle are supplementary to each other. Okay. And what is a diagonal of a quadrilateral? So diagonal. Which one we call it as a diagonal of a quadrilateral? If you join two opposite vertices. As I said you, these B and D are opposite vertices, right? If you join the opposite vertices, then the line segment formed, we call it as a diagonal of a quadrilateral. See, these two are also opposite vertices, A and C. These, if you join this A and C, we call this as a diagonal of one more diagonal of a quadrilateral. So how many diagonals are possible in the quadrilateral? Two diagonals are possible in a quadrilateral. So, okay, next we'll see what are the sum of all interior angles of a quadrilateral. So this is angle A, B, C, D, right? If you draw a diagonal of a quadrilateral, see this is a line segment joining the two opposite vertices. This we call as a diagonal. This diagonal divide this quadrilateral into two triangles, isn't it? This is angle A and this we call it as a angle X and this is Y. Somewhere here this is Z, this is W and this is angle C. Now we know very well the sum of these three angles in a triangle is 180 degrees. Yes. So which is nothing but angle A plus angle X plus angle Z, which is equal to 180 degrees. And in this triangle BCD, what happens? Angle Y plus angle C plus angle W is equal to 180 degrees. We know very well angle B is nothing but angle X plus angle Y, right? We know angle B is nothing but angle X plus angle Y and angle D is equal to angle Z plus angle W. Okay. Now what we need? We need all sum of all interior angles, right? Which is nothing but angle A plus angle B plus angle C plus angle D. Okay. So we know angle A, angle B is nothing but angle X plus Y, right? Angle X plus angle Y and angle C and angle D is nothing but angle Z plus angle W. Okay. Now we know very well angle A plus angle X plus angle Z is equal to 180 degrees. Angle A, angle X and angle Z. These three will become 180, right? So 180 plus and angle Y plus angle C plus angle W is equal to 180 degrees. Okay. Now The sum is 360 degrees. So this is how we can say the sum of all interior angles of a quadrilateral is always equal to 360 degrees. Okay. Now we'll see what is the sum of all exterior angles of a quadrilateral. We'll see. We know these are interior angles, okay, at each vertex, and there is an exterior angle at each vertex. This is exterior angle at C. This is angle C. This is 180 minus angle C. And this is angle D. This is 180 minus angle D. And this is angle A. And this exterior angle is 180 minus angle A. And this is angle B, and at here 180 minus angle B. Now we have to calculate what is the sum of all the exterior angles of a quadrilateral, which is nothing but 180 minus angle A plus 180 minus angle B plus 180 minus angle C plus 180 minus angle D. Okay, which is nothing but 180 into 4, 720 minus this sum angle A plus angle B plus angle C plus angle D. Okay, we know very well the sum of all interior angles of a quadrilateral is 360 degrees. So which is nothing but 720 minus 360, which is equal to 360 degrees. So the sum of all exterior angles of a quadrilateral is nothing but 360 degrees. Okay. What are the minimum and maximum number of angles, means different type of angles, right angles, acute angles, obtuse angles in a quadrilateral. So what is the sum of all interior angles, which is nothing but 360 degrees. So what are the different type of angles? If you consider different types of angles, when it becomes, the sum becomes 360 degrees. So those angles we have to calculate. Okay, the first case I am considering 90, 90, 90, 90, which is equal to 360 degrees. Okay, and other case is 100 plus 100 plus 100, 300 plus 60. Okay, 360 degrees. This is one more possibility. And you 60, 70, 80 plus 150. Okay, which is equal to 360 degrees. And we have one more possibilities, that is 120 plus 60 plus 120 plus 60, which is equal to, see, this is 180 plus 180, 360 degrees. And we have one more possibility, that is 60, 60, 60 plus 180, which is equal to 360. So this is different case, we will discuss at the end. And now we will discuss these four cases now. Okay, so now we will count how many number of maximum number of obtuse angles are possible, minimum number of obtuse angles, and maximum number of acute, minimum number of acute. Now we'll see what is the maximum number of obtuse angles are possible in the quadrilateral. See, you check all the cases. So in the first case, not even a single obtuse angle, isn't it? And in the case of second case, we will see 3. 1, 2, 3. 3 are obtuse angles are possible. So is there any possibility that consider all the 4 angles are obtuse angles? No, right? If you take all 90 degrees only, it is becoming 360 degrees. If you take all angles greater than 90, then the sum exceeds 360 degrees. That is why there is no chance of having more than 3 obtuse angles in a quadrilateral. So how many maximum number of obtuse angles are possible? So the maximum number of obtuse angles in a quadrilateral. How many? So 3. We can maximum we can consider 3 obtuse angles in the quadrilateral. Okay, and you check, this is only one obtuse angle, and in this 2 obtuse angles. So okay, and in this 0 obtuse angles. Okay, so the maximum number of obtuse angles are 3. Now, how many minimum number of obtuse angles? So you check all the cases. In this 2 obtuse angles, in this 1 obtuse angle, in this 3 obtuse angles, in this 0 obtuse angles. So even if you don't consider a single obtuse angle also, you can form a quadrilateral. That is why the minimum number of obtuse angles are possible in a quadrilateral is nothing but a 0. Okay. And next we'll count what are the maximum number of acute angles. What are the maximum number of acute angles? See, in the first case, we didn't even consider a single acute angle. So, in the second case, one acute angle is possible. In the third case, three acute angles are possible. In the fourth case, two acute angles are. So, maximum we need. So, how many maximum? Even if you consider three acute angles also, we can form a quadrilateral. So, that is why the maximum number of acute angles are possible in a quadrilateral are 3. Okay. And how many minimum number of acute angles? See, if you consider all the four angles are acute angles, is there a chance of some become 360 degrees? No. That is why we don't take 4 angles acute angles. So, maximum number is 3. And how many minimum number of acute angles are possible? So the minimum number of acute angles. See, even if you don't consider a single acute angle, then also there is a chance of having a quadrilateral. That is why the minimum number of acute angles are 0 and the maximum number of right angles, the maximum number of right angles is equal to, see, in the first case we have considered 4 right angles and in the next case not even a single right angle. Okay, see, maximum we need means if you consider all the 4 angles 90 degrees also, we can form a quadrilateral. That is why the maximum number of right angles are possible in a quadrilateral are 4. Yes, and what are the minimum number of right angles? How many minimum? See, in this we didn't even consider a single right angle. Yes, minimum is 0. Okay. Now, we'll come to this case. Is there a chance of having 60, 60, 60, 180 degrees quadrilateral? So, which is nothing but 60, 60, 60 and so this is 180 degrees. Is this a quadrilateral? No, right? Because this is a straight angle. So this straight angle is not possible in case of quadrilateral. So either it should be greater than 180 degrees or it should be less than 180 degrees. Then only we can say the quadrilateral is formed. Means the figure is formed, simple closed figure is formed by 4 line segments. See, in this only 3 line segments. We don't call this as a quadrilateral. That is why this case is not possible. This is not possible in case of quadrilateral. Okay. They ask how many number of straight angles are possible in a quadrilateral. You should say 0. No, we should not consider straight angles in a case of quadrilateral. So now we will discuss about relation between the sides and diagonals of a quadrilateral. See, you take one quadrilateral. This is a quadrilateral ABCD. So we always represent a quadrilateral with quadrilateral ABCD like this. Okay. So this is a quadrilateral. And what are the diagonals? This is AC diagonal and this is BD diagonal. Now see, you consider this triangle first, BCD triangle. What happens in the triangle? We know the sum of the two sides are always greater than the third side. If you consider this BCD triangle, what happens? This BC plus CD is always greater than BD, isn't it? and you consider this ABD triangle. What happens? AB, the sum of two sides AB and AD, which is always greater than the third side, which is nothing but BD. Okay, what happens? The sum of any two sides of a quadrilateral is always greater than the diagonal. So this the first point. So the first relation is adjacent sides of a quadrilateral is always greater than the diagonal. Okay, so these AB and BC are adjacent sides. Yes, these two sum is always greater than the diagonal AC. Yes, we can write this AB plus BC. These are the sum of two adjacent sides which is always greater than the diagonal. Okay. And this AD plus CD is also greater than AC. Okay. And so the second property is second relation is the sum of all the sides of a quadrilateral, which is nothing but AB plus BC plus CD plus AD, which is nothing but sum of all left side terms, and you also add sum of right side terms. Okay. So what happens? This is 2AC, right? So which is nothing but sum of all the four sides of a quadrilateral, which is always greater than twice of its diagonal. Third relation is sum of all the sides of A, which is nothing but sum of all the sides of a quadrilateral, which is always greater than sum of the diagonals, which is nothing but AC plus BD. See, we have three relations. One is the two adjacent sides are always greater than its diagonal. Okay. And the next one is sum of all the four sides of a quadrilateral is always greater than the twice of the diagonal. And the third relation is sum of all the sides of a quadrilateral, which is always greater than sum of the two diagonals of a quadrilateral. So this is the relation between sides and diagonals of a quadrilateral. Okay. Thank you.